In this video, I will discuss a JEE Advanced PYQ from the topic Electrostatics. This question is based on finding electric field and the potential due to distribution of charges. Let me consider a system of point charges Q1, Q2, Q3 and so on. So electric field due to this system at any point, say P. So this electric field is given as electric field due to this charge 1, E1, plus electric field due to charge 2, Q, E2, plus third charge, electric field 3, and so on. You have to add all the electric fields. Well, electric field is a vector quantity, so the sum is a vector sum. So this is superposition principle, where the net effect is sum of individual effects. Similarly, the potential at this point can be got from the individual potentials as V1 plus V2 plus V3 plus so on. But the potential is a scalar quantity, so the sum is a scalar sum. Another basic thing is electric field due to a charge Q at a distance D is force on unit charge, unit positive charge, which is 1 coulomb SI units. So electric field due to this charge Q at this location is 1 by 4 pi epsilon naught into Q into 1 by distance square. So it's basically force on 1 coulomb. With this understanding, you can solve this JEE Advanced PYQ. This is the question. 6 charges are placed around a regular hexagon of side length A as shown in the figure. 5 of them have charge Q and the remaining one has charge X. The perpendicular from each charge to the nearest hexagon side passes through the center O of the hexagon and is bisected by the side. Which of the following statements are correct in SI units? Option A, when X is Q, magnitude of electric field at O is 0. B, X minus Q, electric field at O is Q by 6 pi epsilon naught A square. Option C, when X is 2Q, potential at O is 7Q by 4 root 3 pi epsilon naught A. And option D, X is minus 3Q, potential is 3Q by 4 root 3 pi epsilon naught A. You can pause and attempt this question. It's a simple question. You have to make use of the symmetries. Option A, this charge X is Q and you have to find the electric field at this point O. Option A, when X is Q, electric field at O. So to find the electric field, assume there is 1 coulomb charge here and we have to find the force on this 1 coulomb charge. So force due to this Q will be in this direction and force due to this Q will be in this direction. Let me assume Q is positive, so there will be a repulsive force between this and this, and between this and this there will be in this direction. So these two forces are equal in magnitude and opposite directions, so they will cancel. Equal in magnitude because it's Q into 1 by the distance square, and here it's Q into 1 by the distance square, and both the distances are same because all these charges are placed symmetrically around the hexagon, and force due to this Q will be a repulsive force in this direction, and due to this Q will be a repulsive force in this direction. So these two will cancel. And due to the top charge, there will be a repulsive force downwards, and due to this bottom charge, there will be a repulsive force upwards. So these two will cancel. So the net force, which is the electric field, is 0. So electric field in the first option at point O is 0. Option A says the electric field at O is 0. So option A is true. Option B, when X is minus Q, electric field is. So this charge is minus Q now. So the repulsive force will become attractive force. The force due to the bottom charge will be attractive force and will be in this direction. The remaining force will be same. So force due to this one, and force due to this one, they will cancel. Similarly, force due to this and force due to this will cancel. Force due to this is repulsive force downwards, and force due to this minus P is attractive force downwards. So these two will add to give the net electric field at point O as 2F, where F is one force. And that F can be found by Coulomb's law as 1 by 4 pi epsilon naught into Q into 1 by the distance square. Let me call this distance as D. And this is also the same D. All the charges the same distance from the center. The side of hexagon is A. So from here to here, it's A by 2. And the distance from here to here, it's D by 2. Because this line joining this Q and this O is bisected by this hexagon side. So in this triangle, if you know this, that angle is in hexagon. There are 6 triangles like this. So this angle is 60 degrees because all the sides are equal. It's a regular hexagon. So this angle is 360 by 6. That is 60. So this angle is half of that, 30 degrees. So if you take tan 30, opposite side A by 2 by D by 2. So from this I will get D as A by tan 30. Tan 30 is 1 by root 3. So A root 3. So have this relation D equal to A root 3. So if I eliminate D here, D square will become A square into 3. So this force for the electric field, so 2, 4 is there, will become 2 and 3. So 1 by 6 is the numerical factor, and pi epsilon naught may be charged by distance square, this A square. D is A root 3. So this is electric field in the second case. Electric field is 1 by 6 pi epsilon naught Q by A square. So B is also true. Third option, C option, charge is 2Q. So to find the potential at this point O, potential to the individual charge is 1 by 4 pi epsilon naught into Q by D. And the second is also Q by D. So this Q by D will happen 5 times. Plus this last charge will have 2Q. So totally 7Q. So it's basically 1 by 4 pi epsilon naught into the total charge by the distance. Because all charge is same distance D. And individual charge, if you add them up, it will give the total charge, so 7Q. So numerical factor is 7 by 4. So, and then D has to be written in terms of A. So D is A into root 3. So numerical factor is 7 by 4 root 3, 7 by 4 root 3, and then pi epsilon naught Q by A. So C is also true. Option D, X is minus 3Q. So in this case, the total charge potential V is 1 by 4 pi epsilon naught Q by distance. Distance is same for all the charges, so it will be total charge. Total charge is 5 minus 3 will be 2. 2q. So the numerical factor will be 1 by 2 root 3 and then pi epsilon naught into q by d. Option D 1 by 2 root 3, 1 by pi epsilon naught q by e. Sorry, it's q by e. Root 3 has come, so this will be e. But option D, the numerical factor is different, 3 by 4 root 3. It's 1 by 2 root 3. So D is not correct. So this is the correct answer. A, B, C are true. D is false. So this is what I explained here. Electric field is force on 1 coulomb charge due to the source charge. This is the definition of the electric field. In option 1, all the 6 charges surrounding it are equal. So it will be repelled equally in all 6 directions. And all the 6 directions are equally spaced. So the net force will be 0. In the second option, the force due to the this charge and this charge will cancel, this charge and this charge will cancel. Here there will be repulsive force downwards and here will be attractive force downwards. So there will be 2F net charge acting on this center 1 coulomb charge. So net force is 2F and F is K into Q by D square and D is A into root 3. So we'll get 1 by 6 pi epsilon naught. So option B is true. Option C, the total potential is K into total charge by D. Total charge is 7Q. So it's 7 by 4 root 3. Fourth option, the total charge is 5 minus 3 because the third X charge is minus 3Q. So total charge is 5 minus 3. So it will be 1 by 2 root 3. So option D is not true.